The title of this innovation is Reducing Fuel Consumption in Road Vehicle Using Basebleed. The innovators of this innovation is Dr. K. M. Paramasivam, Mr. G. Sivaraj, and Mr. M. Sendil Kumar. The main objective of this innovation is to reduce the fuel consumption of road vehicle using reduction of drag force by placing basebleed. In India, most of the vehicles operate petroleum-based engines, and the average fuel consumption of petroleum is 4.1 million barrels per day. And every year, fuel consumption is increasing alarmingly at 5%. Hence, a small amount of reduction in fuel consumption of the road vehicle will be a great achievement. Generally, when a car moves forward at speeds above 60 km per hour, high pressure and low pressure zones are created at the front and rear side of the car respectively. The overall aerodynamic drag force is reduced by eliminating wake region at the rear side of the car and reducing pressure in the front region of the car by delaying the flow separation. This improves the overall aerodynamic performance of the car, thereby reducing fuel consumption as well as improving stability and comfort by the attachment of basebleed. The basebleed consists of two converging hollow tubes, and the cross-section area of the front side tube is greater than the rear side. Both tubes inject low-velocity air at the rear side by sucking the air from the front side. These hollow tubes are located under the flow of the car without disturbing any existing system or structure of the car. Due to the implementation of basebleed in the car, the flow separation will be delayed on the car surface, and also wake is removed entirely due to the creation of pressure energy in the form of fluctuation energy. Fluctuation energy is created by the entry of air through both the basebleed tubes, which hits the wake energy directly. The drag force is reduced by air sucked from the front side of the vehicle. This in turn will create low pressure zone at the front side of the car. The air can flow from the basebleed at different speeds, and the flow is directed towards low pressure zone so that it can reduce the negative pressure and increase the reduction of drag. The 1:12 scaled models are tested in the wind tunnel laboratory at Madras Institute of Technology. The wind tunnel has a test section of 4 feet width, 3 feet height, and 5 feet length. The maximum velocity is 40 meters per second approximately, and the contraction ratio is 9:1. Air velocity is measured with a pitot-static tube, which is attached to the ceiling of the wind tunnel section. The aerodynamic forces acting on the scaled models are measured with external balance for various speeds. The car model is fixed to 3-component balance through the platform acting as a road at connecting points under the rear and front wheels. The platform is built to stimulate the road condition at such height so as to provide more uniform flow from the bottom of the wind tunnel test section, and also ensure that the model is outside the boundary layer. The leading edge of the platform is sharpened to create a smooth start of the boundary layer. The model is 23 centimeters long, 15 centimeters wide, and 10 centimeters high, and the overall dimensions represent the scale down, that is 1:12 of a real hatchback car. We shall now discuss the experimental results obtained from the wind tunnel tests. With the attachment of basebleed for car model tested at different phase-change velocity, CD, that is coefficient of drag value, is reduced from 0.3329 to 0.3123 due to the elimination of the wake region at the rear side of the car, but the coefficient of lift and side forces does not change significantly. This basebleed also maintains the streamline, controls the lift force and airflow towards the low pressure zone at the rear side of the car. The maximum rate of reduction in drag coefficient was achieved from 6.188% to 12.53% by installing basebleed at optimized location in the car model. In turn, the fuel consumption was reduced up to 4.33% to 8.77% in the real hatchback car running at highway speed. Thank you.